Hello everyone, let us see in this video some tricky concepts of parabola. Let us directly come to the concept. The concept number one is this. Uh, so image of focus of any parabola with respect to its any tangent always lies on its directrix. This is a very famous concept and its application is very wide. In some of the trickiest question we apply this concept that image of focus in any tangent lie on the directrix. Let us visualize the situation first. What could be the situation? So let us say that there is a parabola. Let's say that this is the y-axis. Let us first draw the parabola and let's visualize what can be the situation, what can be the probable situation. Let's say this is y-axis, this is x-axis, and let's say this is the parabola. And let us suppose that S is its focus. So obviously S will lie on somewhere on the axis of the parabola. Its coordinate is a comma 0 if the equation of parabola is y square equal to 4x. And now suppose that this is the tangent of the parabola. Let us say any random tangent. It's not necessary that any particular tangent, because this concept is true for all tangents. So let us say this is any random tangent of the parabola. Now if I take the image of this focus S with respect to this tangent, so we know that if we place a plane mirror along the line of the tangent, that the image of this focus S, that shall be, let's say that is S dash. So that lie on the directrix x equal to minus a. So this is the, I think this is very clear to you, each one of you, that the focus of, sorry, the image of the focus S a comma 0 with respect to any tangent, any random tangent, lie on the directrix, that is x equal to minus a, if the parabola is y square to 4x. So this is the concept number one, which is lesser known, I think, if not lesser known, that lesser used actually. This concept is not used that much in solving the questions, but in some of the trickiest question we use this concept. And the other concept that we should definitely learn before you are going to attempt the J advance. So let's come to the concept number two. So what is the concept number two? So concept number two is this. Suppose that we draw tangents at the ends of any focal chord. Now this is very popular concept, very popular concept, and most of you, I think all of you, majority of you must be knowing this concept, that if we draw tangents at the ends of the focal chord, then these tangents intersect each other perpendicularly. What I mean is that if I draw two tangents at the two ends of the focal chord, then angle between these tangents will be 90 degree, and the point of intersection of the tangents will again lie on the directrix. So let us again visualize with the help of the diagram that what do I mean by saying this. That suppose that this is the x-axis and this is y-axis, and let's draw the parabola. Let us say this is the parabola y square equal to 4x. Assume this is standard parabola y square to 4x. And suppose that I am drawing two tangents at the two ends of the focal chord. Okay, so let's say this is the one tangent at the one end of the focal chord, and let's say there is another tangent that is passing through, or you can say that is touching the parabola at the other end of the focal chord. What I mean is that, let's say that this is one end and this is the other end. If I join these two, so we'll get a focal chord. Then the point of, first of all, the first thing is that the angle between these two tangents will be 90 degree, and directrix will pass through the point of intersection of these two tangents, and angle between tangents will be 90 degree. And if we join the two ends of the focal chord, we'll definitely get the focal chord, and the point where focal chord intersects axis of parabola will be the focus of the parabola S a comma 0. Let us say the focus is denote focus by S. The coordinate of focus is S a comma 0 in case parabola is y square equal to 4x. So the extended concept is that if I assume this focal chord uh, as a diameter of a circle, and if I draw a circle assuming this focal chord as diameter, then this circle will touch the directrix at the point where the tangents are intersecting. And this is very obvious, because if any chord of a circle subtends 90 degree at any point on the circumference, then that chord must be the diameter of the circle. And this is very clear to each all of us, that this circle, if I assume that this focal chord as the diameter, and if I draw a circle, let's say focal chord is PQ, then directrix will be the tangent of this circle at the point where these two tangents of the parabola are intersecting. And this is very powerful, very powerful concept that is going to be used in the coming questions in this video. So wait for the question. So I hope that these two concepts, let's say this equation is x equal to minus a, definitely this is the equation of the directrix. And these two concepts, the concept number one, the concept number two, it's so much powerful that even the trickiest of the tricky questions can be solved using these two questions. And in this video, I'm not going to solve too many questions. I'll show you one question which is very perfect to use all these concepts in just a single question, and you will be amazed at the end of the video that how brilliant these concepts are whenever we face any question which is not so simple. So let us say one question based on these concepts. The question is, a parabola touches x-axis and y-axis at the points 2, 0 and 0, 3. So 0, 3 respectively in first quadrant, right? So the parabola is touching x-axis at the point 2, 0 and y-axis at the point 0, 3 in the first quadrant, right? So only this much information, and we have to find the equation of the parabola. So how can we find the equation of the parabola if the parabola is touching x-axis at 2, 0 and y-axis at 0, 3 in the first quadrant? Obviously, if parabola is touching these two axes, then that must lie in the first quadrant only. So yes, our objective is to find the equation of the parabola. Okay. Now what I want is that all of you should pause this video right here, and you should devote some time in solving this question without looking at the solution of this question that is coming in this video. And because this question is what I believe is, this question is a very good question, and those who are able to crack this question and who are able to get up to the final answer of this question are really super, and their preparation is really very good for the preparation of JEE Advanced. So suppose that this is x-axis, y-axis, and this is the parabola. This parabola is touching y-axis and x-axis. X-axis at point 2, 0 and y-axis at point 0, 3. Now that we can see that x-axis and y-axis both are its tangent, and the two tangents are intersecting at origin. Now the main point to see here is that the two tangents are intersecting at right angle, which means that this is possible only if these tangents have been drawn at the ends of the focal chord. What I mean is that if I go to the concept number 2 and I will check that if the tangents are perpendicular, then which means that tangents must have been drawn at the end of the focal chord. Let us say this green line is the axis of symmetry of the parabola. It is not necessary that this axis will pass through the origin. Let us say this axis is passing through just anywhere, and if I join the 2 points 0, 3 and 2, 0, we are getting the focal chord, and the focal chord is intersecting the axis at the point focus. So the point where this focal chord is intersecting the axis, let's say this focal chord is PQ, the point P is 0, 3 and the Q is 2, 0. So this point must be the focus, and we don't know the coordinate of the focus yet. But yes, we have got that since the tangents, that is x-axis and y-axis, are perpendicular, and therefore these tangents must have been drawn at the end of the focal chord. So similarly, if I draw a circle assuming this PQ as diameter, then directrix of this parabola must be the tangent of this circle at the point where the two tangents of the parabola are intersecting, that is at the point origin. So if I could find a tangent, equation of a tangent of this circle at the point 0 comma 0, that is origin, then we will definitely get the equation of the directrix of the parabola, right? And this is the directrix of the parabola. Let us write it clearly. Now, since you know this P and Q are the end points of the diameter, and therefore we can easily get the equation of the circle if the end points of the diameter are given. You know the equation of the circle in this case is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So using this formula, I am going to find the equation of this circle, that is x minus 0 into x minus 2 plus y minus 3 into y minus 0 equal to 0, and finally we are getting the equation of the circle as x square plus y square minus 2x minus 3y equal to 0. Now if I use the tangent transformation to find the equation of tangent of the circle at the origin, that is 0 comma 0, what is tangent transformation? All of you must be knowing that if I place x square by x x1, y square by y y1, x by x plus x1 by 2, y by y plus y1 by 2, then we will definitely get the equation of the directrix. So in this case, x1 y1 is 0 0, because the point where we are finding the tangent is 0 comma 0, so x1 y1 0 0. So using tangent transformation, we are going to find the equation of the directrix, that is equation of the tangent of this circle at the point 0 comma 0. So directrix is x into 0, x x1 plus y into 0, y by 1, minus 2 into x plus 0 by 2, that is x plus x1 by 2, plus minus 3 times y plus 0 by 2, that is y plus y1 by 2 equal to 0. And after simplifying, we are getting the equation of directrix is in this case is, as you can see, that minus x minus 3y by 2 equal to 0. So finally, after simplifying and rearranging the terms, we are getting 2x plus 3y is equal to 0. That is our directrix. So now using this concept, we have got the equation of the directrix of the parabola. Still we don't know the equation of the parabola, but we know the equation of directrix of the parabola clearly. Now let's go back to the diagram and let us visualize that what is now required to find the equation of the parabola. So suppose that if I get the if I get the coordinate of the focus, and since we already know the equation of directrix, then in that case, using the definition of the parabola, we can easily get the equation of the parabola. Suppose that we get the coordinate of focus, then, and let's say that there is any point on the parabola, then distance of this point on the parabola from focus must be equal to distance from directrix, and this concept we will use and we will find the equation of the parabola. But before that, we must know the coordinate of the focus. So we know the end of the focus, we know the coordinate of the end of the focus. If somehow we can find the ratio of PS is to QS, if I could find the ratio of PS is to QS, then using section formula we can find the coordinate of the focus. For that, we are going to again use the definition of the parabola. So distance of any point from the focus must be equal to directrix. Therefore, distance of point P from the focus must be equal to distance from directrix. So P is equal to PM. And as we know that this perpendicular distance of any point from the any line, we are going to use that formula. And then from there we have to find the equation of this length of PS equal to PF, that is equal to 2 into 0 plus 3 into 3 divided by 2 square plus 3 square, that is equal to 9 divided by under root 13, right? So this is your PS. And if we are going to find distance of point Q from S, then let us draw a perpendicular from Q to the directrix, that is Qn, and the point Q is 2 comma 0. So again, if we find QS, so that is equal to Qn. So QS should be equal to Qn, and again using the formula of the perpendicular distance of a point from a line, we are obtaining that QS is equal to again 4 by root over 13. So in this way we got the ratio of PS is to QS smartly, and now using section formula we can find the coordinate of the focuses. So PS is to QS is equal to 9 by 4, and therefore applying section formula for internal division, we are going to find the coordinate of the focus S. So coordinate of the focus S should be equal to, now up till here it should be equal to Let us apply mx2 plus nx1 divided by m plus n, because it is m by n is 9 by 4. So 9 into 2 plus 4 into 0 divided by 9 plus 4 m plus n, and again 9 into 0 plus 4 into 3 divided by 9 plus 4. So finally we are getting the coordinate of focus as 18 by 13 and 12 by 13. Y coordinate is 12 by 13. Now we know the equation of directrix, we know the coordinate of focus. So now we can attempt to write the equation of the parabola very easily. Let us assume that there is a point on any point. Let us assume there is any point x comma y on the parabola. Let us assume anywhere. Let us assume that this is there. X comma y is this point. Let's say this point is x comma y. So by definition of parabola, distance of this point from focus must be equal to distance of this point from the directrix. This is the definition. We know the definition of the parabola. And since this is any random point on the parabola, so equation of parabola can be easily obtained, that distance of this point from S equal to distance of this point from the directrix. So therefore square root the distance formula, we are using the distance formula between x comma y and focus. So x minus 18 by 13 whole square plus y minus 12 by 13 whole square. This is distance of from focus equal to distance from directrix. So distance from directrix is distance of any point from any line. That formula we are going to use, and you are finally very close to getting the answer of the equation of the parabola. And 2x plus 3y divided by root 2 square plus 3 square, and then squaring both sides and rearranging the terms. Now it is just a matter of calculation that you will get the equation of the parabola. So I hope that this video should add to your knowledge two concepts at least, and not in fact two concepts, rather more than two concepts. There are too many things within one video to learn, and these are some lesser used concepts, and that is used in some trickiest question of the parabola. There are some other properties also, of course, of the parabola that is used elsewhere, and that is also used in the trickiest question. But this property is the property that is very much used, very much helpful in solving the question of the parabola. Hope you have liked this video and you learned a lot from this video. See you in the next